In this video, we will learn something about projectiles. Okay, to start with, we will start with few images. Okay, the screen that you're seeing here now, it's a cricket match. So you see here, the ball just moved from the bat to the boundary. It crossed some path. And the next one, you can see here, you would have seen all these projections in the matches shown, how many fours, how many six, what was the path traced by the ball. These projections will be shown in the match. And coming to the game in Angry Birds, you would have seen this projection even, right? So the particle will be thrown with an initial velocity of u at an angle alpha. This velocity will have both horizontal u cos alpha and vertical component. So therefore, a particle projected upwards at a certain angle moving under the combined effect of vertical and horizontal components of velocity is called as a projectile. The path traced by the projectile will be parabolic. You can see here, in all those examples what we saw, the certain particle might be a ball or that angry bird, whatever it is, when thrown with certain velocity, that is the initial velocity u, it follows some parabolic path like this. Okay, starts here and strikes back to ground here. And you see the horizontal and vertical component of this initial velocity. So this is the definition of a projectile. So you can see here how the horizontal and vertical components of this velocity varies with this projection of the ball here. See here? So you exactly see here the variation of the components of the velocity. So when it is at the beginning, you have two components, that is u cos theta or u cos alpha, u sin alpha. When it reaches the maximum height here, where you see at the top, you can only see the horizontal component and the vertical component is completely zero. Once it loses its vertical component, it starts coming down, and when it comes down, the components will be again u cos alpha and u sin alpha, but vertical component will be in the opposite direction. When it started, it was in the vertical direction. When it ends, it will be in the downward direction. Let's see some important terms in projectiles. Trajectory. The path traced by the projectile in the space is known as trajectory. So you see the path traveled by the projectile from the beginning point to the end. So that is trajectory. Velocity of projection, the velocity u with which a projectile is projected into the space is called as velocity of projection. So you saw the term u with which the particle is thrown, initiated. Angle of projection, it is the angle alpha with horizontal at which the projectile is projected. So you throw the particle with certain angle with respect to the ground surface or the horizontal you consider. So that is called as angle of projection. Here we take it as alpha. Time of flight. The total time t taken from projection to reach maximum height and then written back to the ground is known as time of flight. So the total time taken by the projectile to travel from the starting point to the ending point is called as time of flight. Range. The distance between the point of projection and the point where the projectile strikes the ground is known as the range. So the horizontal distance traveled by the projectile is known as the range. Next is motion of the body thrown horizontally into the air from certain height. So initially we saw a projectile where it starts from the ground and ends at the ground. And now we are going to check where the particle is going to start from a certain height and then going to end at the ground. And it is going to travel a parabolic path. So you can see this figure here. So an airplane or aircraft is dropping a bomb. It wants to drop the bomb and this is its target. So it drops it at this position and the bomb travels with certain speed and reaches here like this. Right? So if you want to solve problems on that, you can see here the aircraft is coming with certain velocity v or u. With the same velocity the bomb will be dropped at certain height the aircraft will be traveling. So I call it as h, and it is going to travel this path and drop it on this person. So this will be its horizontal distance traveled, and this will be its height, maximum height, and this horizontal distance traveled is called as range. So the time taken by the particle to reach ground can be calculated using h is equal to half gt square. So the height will be already known. If we want to calculate time, we should make use of this formula, that is h is equal to half gt square. So horizontal range can be calculated using r is equal to ut. That is nothing but distance is equal to velocity into time. It's a simple formula. So if you want to calculate time, this is the formula. If you want to calculate the range, this is the formula under such problems. So to build the equation to the path of the projectile, so we have a diagram here, proper projectile where it starts from the ground and ends in the ground. So I'm taking the two-dimensional direction, and the projectile is going to start from here O, and it's going to travel via P, reach a maximum height, and then come back to A. So it is being projected with certain velocity. I call it as initial velocity, making an angle alpha with the horizontal. So this velocity will have its horizontal component, that is u cos alpha, I call it as ux, and vertical component uy, that is u sin alpha. So consider a particle projected from O at certain angle alpha with horizontal. The particle will have a trajectory path OPA in air and strikes the ground at A. So referring to this figure, I'll proceed further. The horizontal component of velocity ux is equal to u cos alpha. The vertical component of velocity uy is equal to u sin alpha. The distance traveled in t seconds after projection in horizontal x and vertical y directions are given by x is equal to ux into t, that is u cos alpha into t. We know that horizontal velocity is u cos alpha, that is the horizontal component of the velocity is u cos alpha. So I call this as equation number 1. Then I want in vertical direction, that is y is equal to uy into t minus half gt square. So this equation is because it's in the vertical direction. When in the vertical direction, there is the effect of gravity. So that's why we take the equation of motion as y is equal to, I'm substituting it, u sine alpha into t minus half gt square. I call this as equation number 2. So from equation number 1, I can rewrite this as t is equal to u cos, t is equal to x by u cos alpha. From the equation number 1, I can write it as, I call this as equation number 3. So substituting this equation number 3 in equation number 2, that is for, if I substitute for the time here in this equation, I get it as y is equal to u sine alpha into x by u cos alpha minus half g into x by u cos alpha whole square. So upon solving this equation, I get it y is equal to x tan alpha minus gx square divided by 2u square cos square alpha. I call this as equation number 4, and it's very important and we need to remember this. So this particular equation is the equation for the path of projectile, and this resembles the parabolic path, equation for parabolic path. So this forms the basis for the projectile. Y is equal to x tan alpha minus gx square divided by 2u square cos square alpha. So this represents the equation of parabola. Coming to the second part, that is to find the horizontal range. The horizontal distance traveled by the projectile is known as range. Substituting y is equal to 0 as the particle hits the ground and x is equal to r in equation number 4. The equation that you have remembered there. If you substitute there y is equal to 0 and x is equal to r to find the horizontal range. That is, y is equal to x tan alpha minus gx square divided by 2u square cos square alpha. In this equation, I'm substituting y is equal to 0 and x is equal to r. I get it. 0 is equal to r tan alpha minus gr square divided by 2u square cos square alpha. From here, I can write r is equal to u square sine square alpha by g. So this is the equation for range, and I call this as equation number 5. We need to remember this even. From the equation of the projectile, the path of the projectile, to get the range, I substituted y is equal to 0 and x is equal to r. So I got r is equal to u square sine 2 alpha by g. For maximum range, sine 2 alpha is equal to 1. Okay. Um, So I can write 2 alpha is equal to 90 degree, therefore alpha should be 45 degree. So substituting this in equation number 5, I can get maximum range to be R max is equal to u square by g. So this is the condition, this is the maximum range we can obtain. The condition for that is alpha should be 45 degree. The projectile should be thrown at an angle of 45 degree. Coming to the third part, that is to calculate the time of flight. The time that is required to hit the ground from its projection. It's called as time of flight. Substituting y is equal to 0 in equation number 2, that is, y is equal to 0 is equal to u sine alpha t minus half gt square. If we substitute y is equal to 0 here, we can write t into u sine alpha minus gt by 2 is equal to 0. So there are two conditions here. Here, t is equal to 0 at the beginning. During the time of flight, when it starts, there are two conditions. At the beginning, t is equal to 0. But we need to know when it completes, when the projectile is completed, that is at the end, when the time ends. That is the next condition. So we can take u sine alpha minus gt by 2 is equal to 0. So this equation consists of two parts. Either to get this equation as 0, either t should be equal to 0 or this term should be equal to 0. T is equal to 0, we know that it is at the beginning. So obviously this condition should be at the end. So I take u sine alpha minus gt by 2 is equal to 0. Therefore, I get the value for time, that is time of flight, is equal to t is equal to 2u sine alpha by g. I call this as equation number 6, and this is something you have to remember, this equation. So first we saw the equation of the path of projectile, then we saw the range of the projectile, and third one we saw the time of flight. And the fourth one will be calculating the maximum height of the projectile on a horizontal plane. So let h be the maximum height reached by the particle. The total time of flight, that is t is equal to 2u sine alpha by g, that just we derived. Hence, time taken by flight to attain maximum height is t by 2. So to complete the whole parabola from starting to ending, the time taken is t is equal to 2u sine alpha by g. To exactly attain the maximum height, it will be exactly half of this time. So I take t by 2 to reach the maximum height. So once I get the time, I can easily calculate the height. So maximum height of the projectile h is equal to uyt minus half gt square. So same condition, s is equal to ut plus half gt square. In the same condition, I'm going to take the height since height is affected by the gravity. So h is equal to, I'm going to substitute uy, that is u sine alpha, into the time. I'm going to take it as half of the time since I'm calculating the maximum height. So this time I've substituted as half of this time of flight minus half g into, again this time should be substituted as half of this whole time of flight. So substituted here together whole square. So upon solving this, h is equal to u square sine square alpha by g minus half u square sine square alpha by g. So h is equal to u square sine square alpha by 2g. So this is the equation for maximum height reached by the projectile on a horizontal plane. So until what we learned, the list of formulas is as follows. First, we learned the equation of the path of projectile, that is this equation. Then we calculated the horizontal range, r is equal to u square sine 2 alpha by g. Then we calculated the time of flight, that is t is equal to 2u sine alpha by g. Then we calculated the maximum height, h is equal to u square sine square alpha by 2g. In addition to this, we learnt motion of the body thrown horizontally into the air, that is the bomb dropping problem. To calculate time, we require h is equal to half gt square. To calculate the range, we need r is equal to ut. So these are the set of equations that we need to remember to solve problems in projectiles. Some important questions here. Define the important terms in projectile, that are trajectory, angle of projection, velocity of projection, time of flight, range. And with the usual notations, obtain the expression for equation of the projectile, time of flight, and maximum height reached by the projectile. So all the derivations that we did. These are the references made here. Thank you for watching this video, and in the next video we will solve problems on projectiles. Thank you.